Welcome to the March 20th, 2024 SIG Cloud Provider Extraction meeting. As always, this is a meeting sponsored by the CNCF, and we are, we like to hold ourselves to the CNCF policies, most of which amount to just be a reasonable, nice person and respect others and treat each other with kindness. With that, I'd like to go ahead and get started. So there is an existing issue that I think people were interested in, which is issue 586 from the APIServer network proxy. And Imran is here, had some, I think, good questions on the rationale behind the transfer channel sizes being set to 10 and 150. This is a complete mea culpa on my side. These numbers come from me. And they weren't necessarily, I would say the reasoning behind them is less about, I can say definitively these are the right numbers, as when I did some performance testing, these were the right numbers that I came up with. So I would say the first thing to do is look at, I think, 2 of the PRs where this was introduced. So I'm currently showing issue 277, which adds a block check. This is acknowledging at some level that these may not be the right numbers. And so this is making sure that if you have the warning flag turned on, that you will get the error message that I believe Imran saw, so that we could come back and have exactly this discussion. There is also a slightly older PR 269, which is causing, it has to do with improving the debugging for anything causing problems sent to the proxy server. So a little background, and then I'll go ahead and open it up to others. So the transfer is essentially it is a pipe or a go channel between reading data from one end of the connection and then writing it back out to the other. And when the code was originally written, we didn't actually set a size, which implicitly means that it is a size of 1. And that meant that every time that you read a packet and sent it to the other, to then be written on the other side, you couldn't read any new messages, and there was no buffering between, so you ended up with a sort of impedance on either side affecting the other. So I added the channel size so that we could disconnect to that impedance, and then I built a little performance test where I was essentially kubectl copying a large amount of data in and out of a given pod. So this is forcing all the data to go through the API server, and hence through the API server network proxy to a single pod, which meant through a single network connection, which meant through a single API server network proxy connection, and then worked out how large I needed to bump those channel sizes until I stopped seeing the instrumentation that said that we were hitting a problem, that there was, the buffer wasn't big enough. And basically once that happened, and I was copying like gigabyte file kind of things, I was like, okay, this seems to be a good point, and I will go ahead and just leave it here and figure if these aren't big enough that at some point in the future, and this is 3 years in the future, we can come back and determine if we actually need to either bump these up or make them configurable. So that's the background on where the specific number 10 and 150 came from, which is basically they came from a performance test, and I always knew there was a good chance we were going to have to change them. I believe that the proto version of this group at the time actually quizzed me on this, and I will make the same observations I made then, which is that these are just buffers. So at some level, if you have a significant enough impedance mismatch between reading and writing on any one of these sets of communications, and it doesn't go away, then you're going to grow without bounds, and that is not the intent. I mean, there's no way we can fix that problem. So, I mean, the idea of we need a large enough buffer to deal with spikes, I think, is a really good argument, and these may not be big enough to deal with spikes, but I do feel the need to point out that they will never be able to deal with anything except a spike. If there's a sustained impedance mismatch, then any number is going to be not large enough. So I think that's my piece said. Imran, I know you had asked the question. I don't know if that kind of answers. And then even if it does answer the question, I think then the follow-on is, do we want to bump? Do we want to make these user configurable? How are you feeling on that? And you are muted.
Thanks, Walter. That was really nice of you to give that complete background context of it. So while I was trying to understand like what could be the reason behind these values, I also thought of, okay, we can have those values as a default values and make it user configurable. But then the question second came was, what value is a good value, or if the user is configuring it, what is a large value that does not impede anything else in terms of performance or anything? I mean, if you want to make it configurable, 150 or 250 or 350 or whatever the number be, what is that same number that we are talking about? Because you had the historical context of doing that performance testing and finding out that, okay, 150 seems a sweet spot, but I never had that context. So that question kept coming back to me. Even if it's user configurable, what should the sane value be?
Yeah, I think it's a great question. I mean, the interesting thing is, if you think about the API server network proxy, it's sitting between your cold control plane and your data plane. And it's specifically managing traffic that was initiated by the Kubernetes API server. So that traffic is going to be things like if you kubectl copy or kubectl proxy or do any of those sort of commands, or if it's webhooks, anything where you expect the traffic to have been Kubernetes Kubernetes API server initiated, is the traffic that's going to go over the webhooks, the API server network proxy. And then it's a matter of there's traffic that goes into the API server network proxy and then out again in going to the, and so you've got one pair that is going from the control plane to the data plane, and then you have another pair of communications that are going from the data plane to the control plane. And so anytime in either one of those scenarios, you'll have traffic that comes in and then needs to be written out again. And if for some reason your right channel, the right tunnel, is slower than the tunnel from which you're reading, then you're going to begin to buffer. And essentially that buffer is going to be in terms of the number of items that are getting queued. So most of the time I would expect it to be a message. But that, I could see scenarios where that message could be as small as a packet in some specific scenarios. Most of the time, I would expect it to be a full message. And it's how many of those should the API server network proxy hold on to before it starts throttling its read side, right? So if the number is 150, then you'll be constantly handing things off to the right thread, but at some point the right thread is just way behind your read thread. The read thread will eventually throttle trying to write to that channel, and that stops you from essentially. I mean, if we had an unlimited channel, that what would happen is you'd OOM. As it stands, what happens is you're gonna throttle the input. Neither behavior is great, but you kind of have to accept one of them. And I thought it was better to just try to find a number that you're happy with on the memory side and then throttle there, which is a kind of roundabout way of not answering your question. I think if I had to actually answer your question, I would probably say, you would probably want to slowly push the number up as you experience throttling, and you monitor the memory, and you stop when you decide that the memory has gone up as much as you're willing to let it, or when the throttling stops. Joseph?
Yeah, I just have some dumb questions that I'll ask here because it could be useful for discussion. I see when I search the code that the transfer channel size constants, it's used once in the agent, but it's used twice in the server. And I'm sure it's used once in the forward direction and once in the reverse direction. So if we were to make these configurable as flags, would you agree that we should give the server 2 flags and the agent 1 flag?
I actually think they should both. So here's an interesting one. This is a great question, and it's kind of an embarrassing one for me. They should both have 2 flags is actually the truth of the matter. But if I look at the API server network proxy and I look at, so I'm going to share, and I look at pull requests, and I look at closed pull requests, and I look at closed pull requests from me, and this is something I had noticed recently, and it's my own. You'll notice that there's this PR that was a lifecycle rotten. And Joseph may remember this one. I don't know if he does or not. And essentially, we had a long discussion on this, and a lot of things were in flight. And we never quite all of us were a little paranoid about some of the things that I had done here and probably needed to get worked on. But the essence is that at some level, the agent and server code are the same, right? They're both the agent, they both have reads and writes on either side of the process, right? So on the server side, it's really easy to understand that you have a tunnel on each side. The agent has the tunnel on one side and the actual local network on the other side. But you still end up having reads from the local network need to be written to the tunnel, and reads from the tunnel need to be written to the local network. But we never actually put a buffer in between those. So right now on the agent side, there is basically an unbuffered read-write connection, and that PR is meant to decouple, and that's why you only see one transfer on the agent, is because we never actually added the decouple into the agent. And I think actually we probably at some point should decouple the reads and writes. And so I actually believe that we should have flags, 2 flags in each, but this is why currently we only have 1 transfer channel size in the agent.
Okay, second question, similar topic. If we were to make these configurable as flags, right now these constants are per, I suspect per packet message, and we're just counting up and limiting the number, buffering up to a certain maximum number of those packet messages. Would it make sense to change the semantics to be the size of the data to allow a large number of small messages to be buffered? And then it might be really convenient for an operator to reason about their max pod spec memory limits and the size of these flags.
I think it's a great question, and I don't have a rapid, quick answer to it. I mean, my first thought is it's much more complicated code, right? So, I from a KISS principle, I don't like it. I mean, but maybe KISS is not the right way of viewing this. I mean, there's always value in keeping it simple. On the other hand, keep it simple for whom? I will admit that that's keeping it simple for the coder rather than keeping it simple for the operator, and maybe the right answer is keeping it simple for the operator. I don't know to what degree, like being able to say, please stop at 20 megs of messages. Is that more useful? Maybe. This is probably me having too many weird experiences with Go and containers, but even if we capped it at 20 megs, I'm not sure that that would be visible as 20 megs to the operator. Between redundancy and copying and some issues with Go not always having great garbage collection, I'm not sure that it would actually, it would provably be 20 megs at the channel. I'm not sure it would actually be 20 megs at the process. So I'm not sure if we'd actually realize that win in the way we intended. But I'm also willing to listen to other people's kind of experience. I also just briefly wanted to say hi, Chris. I'm not sure if we've ever met.
Ages ago. Definitely at a contributor summit in the past. You and I sat together.
Nice.
Yeah, I'm mostly just joining in here just to kind of see how progress is going on in these things. We're silently using the network proxy in some of our deployments inside of Apple, and so I just wanted to come and see how things are going. Yeah.
Oh, cool.
Just
all right.
Hang out for a second. So
welcome. Great having you here. Do you, by any chance, know Whitrock?
I do. He is not at Apple anymore, though.
Oh, I didn't know he had moved on.
Yeah, I think about a month ago he moved to NVIDIA.
Oh, well, he's probably happy with the stock price on his recent move.
Yeah, it all depends on when he joined in there. I mean, that thing skyrocketed in the last year. So yeah.
Well, great having you. Please let us know if. All right. So sorry for that distraction, but I wanted to make sure that we're actually acknowledging. So I don't know. Thoughts on that, Joseph, Imran, or Chris?
I have one question just to understand it more clearly. Was Joseph's question towards the a simple way, like a policy enforcement of sorts, where okay, you're not allowed to copy or do something like that more than X MB in a in per execution, and underlying the way we would structure the Go code that would enforce this policy, was that it, or did I understand it wrong?
I'm not sure I fully understood the question, but I don't think that's what it means. It's just a simple Golang primitive. There's I think if you take the proxy server as an example, in one of the directions, there's two separate Go routines. One receiving Go routine is reading from a tunnel segment with a gRPC receive API call, and writing to a fixed length buffered channel. And then some other Go routine is receiving off of that channel. And if the channel ever grows to be fully up to capacity, then the first Go routine will actually block and stop receiving from gRPC in order to sort of not have runaway memory footprint. And the semantics of that full buffer, the most recent question I asked was, should the flag to represent that be in terms of absolute memory footprint rather than in terms of the number of packets? Because you could imagine some TCP traffic that's very fragmented, but not actually very much data.
Oh, okay, I got it then. I thought I misunderstood this question where saying that, okay, this is something enforcing a policy at some higher level where you want to restrict copying of or transfer of data at a particular limit, and that's how we would enforce it by structuring that in the code. So yeah, thanks for that clarification.
Yeah. The other thing that gets a little odd about that is I think if we look at it, each of those buffers is pairwise, or it's either pairwise or it's associated with a particular reader. So if I say 20 megs, that's going to be 20 megs per reader rather than 20 megs. Which again may make it a little hard to do. I'm not saying we can't do it. It's just it is an interesting aspect, right? Is the it's that size times the number of readers potentially.
Is that true on both the server and the agent side?
Yes. Well, yes, but so one, half the readers on the agent side well, let's which one do we want to start with? So on the server side, it's the readers in one direction times one constant plus the readers in the other direction times a different constant. And then on the agent side, half the readers are going to be unbuffered, so there's nothing. And then the other half of the readers will be by that constant. Now, if we fixed the code that I pointed out earlier and actually got that landed, then you're actually dealing with, exactly the same math as the server, except that in general, I would expect the number of readers on an agent to be smaller, but that doesn't have to be true, right? If I somehow had like a HA control plane and only one node, I would end up with more readers on the agent side. But in most scenarios, I would expect the number of agents to be greater than the number of servers. And at that point, you'll end up with more readers on the server side than on the agent side.
I have one question.
Yeah.
Sorry, was anyone speaking?
Yeah, go for it, Imran.
Okay. The question here is that difference in that value, like one constant is 10, the other is 150. Does it have to be sort of in tandem with each other as to how big or small one constant can be relative to the another, or can it be can it be like 10 and 500, or like, does that have to be relative to each other?
Nope, there's no relation between them. If I had to guess, and at this point, sadly, I probably knew at the time, but at this point, I'm guessing. If I had to guess why those numbers are different, it's because the tunnel on one side is on a local network. And so it takes, so when I did the testing, the proxies, the API server network proxy and the Cube API server were running on the same machine, and they may have even been connected via UDS. Anyway, the local file system rather than ever actually touching the network. And on the other side, the server to the agent was over actual network. And in that scenario, you're going one direction is going to need a lot more buffering than the other. And that's probably why I got very different numbers. But that also seemed like a pretty normal configuration where the API server and the network proxy were a lot closer and therefore just needed less buffering.
Thank you.
Cool. All right, we are actually over time. I hope that answered questions. I don't know that we came to a conclusion, but I will say, if someone thinks that we should add configuration, I'm all for it. Also, at some point, I wonder if this actually points out that it may be worth resurrecting my old PR. All right, I'm afraid I do have to. Oh, go ahead, Imran.
Sorry, just one quick question. Is it possible to run that performance test that you did to come up with that value? Because I want to understand the difference between UDS and MTLS. What difference would it make with those numbers? Whether we want to increase those numbers or not. So.
Sure. I mean, in fact, you may want to see if there's a particular performance number for you, but I'll tell you, I went for a very simple test. I literally generated a gigabyte file and then just kubectl copied it into a pod.
Okay.
And in fact, I think I had it set up to be able to kubectl pod into the pod and then back out of the pod.
Okay.
I need to run, but if you're not working it out, let's go ahead and put it in the notes, and I can dig up the steps I took and try and add them back. Cool.
Thanks. Thanks, Walter. That would be great.
All right.
This is really valuable. Thanks, Walter.
All right. Thanks, everyone. Bye.
Thanks, folks. Bye. Take care.